Okay, for the first method that we're going to write in this video, App Academy focuses a lot on merging an array, basically in sorting or finding. So the first thing that I'm gonna be going over is the merge sort. So basically, the idea of merge sort is we're gonna take an array, an unordered array, say 4, 2, 6, let's say 5, 7. Let's do another 5. So basically, the merge sort will split an array into a half until the element, the length of the array becomes 1. So first we're going to do 4, 2, 6. That's going to be the left array. The right array will be 5, 7, 5. Again, obviously the length is not 1 yet, so we're going to be doing it again. So here 4, that's 1, so that's done. So we're going to have another 2 and 6. Here 5. Here 7 and 5. Again, we're going to be splitting 2 and 6 and 7 and 5 here. So we're going to do 4, 2, 6, 5, 7, 5. So I'm going to be doing 5. Get the idea. Here. And finally here. Okay, so now we have split it down to the array length of 1. We're going to be comparing each one. So here we're going to be comparing 4 and 2, and we're going to be comparing the first element of each array. Right now we only have one element in each array, so only thing we're going to have to compare is the element itself. So we're going to compare 4 and 2. Obviously 2 comes first, and then we don't have anything left over in the right array that we're comparing to, so we're just going to put 4 in there. Cool. Now this one is gone. Now we're going to compare 6 and 5. Obviously 5 is smaller, and when we shovel into 5, when we put into 5, we're going to delete it, and then we're going to get 6 here, so we're going to delete that. And then we're going to compare 7 and 5. So obviously 5 is smaller, so I'm going to take 5, and then anything less left over, that is 7. Okay. Here again, we have 2, 4, and 5, 6. So basically, when they are merged, sort of, that means the array that is returned, we can safely assume that they are a sorted array. So here we have 2, 4, and 5, 6 that we are trying to merge. So I'm going to take a look at the first element of each array, 2 and 5, and obviously 2 is smaller than 5, so I'm going to take 2, right? And at the same time, when I shovel into a new array, I'm going to be shifting it. So now the first element becomes 4 on the left-hand side, and the right array of the first element is going to be 5. So 4 is smaller than 5, so I'm going to be shoveling 4 while taking 4 out of there. Well, left array is empty right now, so I can just shovel in 5 and 6, the rest of item here, and that's when I am left over with the result of 5 and 6. So now we have 2, 4, 5, and 2, 4, 5, 6, and 5, 7 on the left side. Also, again, I'm going to be comparing with the first element of each array, 2 and 5. So 2 is smaller. So I'm going to take 2, and I'm going to shift it. Okay, now 4 versus 5. So obviously 4 is smaller. I'm going to take 4. Okay, now 5 versus 5. So they're actually equal. So I can take both of them at the same time, saving another step. Now 6 is the first element of the left side, 7 is the first element of the right side, so I'm going to take 6 here, and finally what now left array is empty, so I'm going to take 7. So now when we have all elements sorted, we got the result of the sorted array. So how are we going to implement that in the coding in Ruby? So basically, we're going to be using the recursive method in splitting the array all the way down to when array length is equal to 1. So here, and then when we have that array with one element, I'm going to use the helper method and merge to help me merge that in a sorted array. So here first I'm going to be splitting it, so I'm going to do return self if self that length is less than or equal to 1. That will be our base case. So basically we're just going to return self, which is the array itself when the array length is 1 or 0. Okay, so I'm going to have to find out the midpoint of it to split an array. So I'm going to do mid is equal to self.length divided by 2. That's going to give us the index of the array where we're splitting. So left is equal to self.take mid, and right array is going to be self.drop mid. And here, what we're going to do is we're going to pass that into our array itself. So sorted left is equal to left dot merge sort. And here, we're going to do sorted right is equal to right dot merge sort. Okay, so when we pass onto the merge sort, we're using the recursion here. That we're going to assume that the left array, when we pass the left array into the merge sort ourselves, we'll do the work of splitting it, and then a sorted array will do the splitting it, vice versa. And at the end, we're going to do merge. We're going to call the merge helper method, and we're going to pass on to the sorted left and sorted right. Yep. Okay. So merge should accept left and the right. Here first, I'm going to start with defining a empty array, which is sorted, that we're going to be using it to shovel into the first element that we're going to compare. So we got the sorted array that is empty, and we're going to loop this until left or right side of the length is 0. Basically, when left side or right side the length of the array is 0, we're just gonna end the loop, and we're gonna just append or add anything that is left over into the at the end of the sorted array. So until left.empty or right.empty. So here we're going to be comparing the first element of each arrays. So if left the first is less than the right the first, so we're comparing the first element of the left and the first element of the right. And then let's say if the left is smaller, I'm going to shovel sorted array. I'm going to shovel the first element into the sorted array. But then here, remember, like when I shovel it, I'm going to have to take out of that element, the first element, from the left array. So I'm going to be using dot shift. So what dot shift does is it's going to return the first element of the left array. At the same time, I'm going to be shifting it, so the first element will be gone. So here, we're going to do else if the left dot first is equal to right dot first. I'm actually going to be shifting both of the first element, so sorted right dot shift. Else if right dot first left and left dot first, I'm going to do sorted is right dot shift and and end the loop. At the end, obviously, we're gonna. So when we get out of this loop, we're gonna be having either a left array empty or the right array empty. So so when we return from the helper method, we want to return an entire array that is sorted. So I'm going to do sorted, which has all the element that is sorted plus left plus right. So if the left element is empty, left plus, like adding left array will not do anything, but then it'll add the right element, the element in the right side, right array will be added to the sorted array. Vice versa, if the right array is empty, the anything that is left over in the left array will be added to the sorted array. Well, that means the anything that is left over in the left array is greater than the last element in the sorted array. So it is indeed sorted. So I think that's gonna be it. Let's test it. So here I am in the console. I'm gonna go to the pry. So I am going to be loading the merge sort.rb. Okay, so let's say a is equal to what example did we use? So 426.575. Oops, got another array sign there. Okay, so when I call a dot merge sort, here we get 2, 4, 5, 5, 6, 7. Cool. So the merge sort works, and that is it for me.